Good morning, eighth grade. This is going to be the last week of uploading videos to show you guys before you all are in here 4 days a week. I can't wait. I'm so excited that you guys get to come back and that we're able to do school the way we want in a way. So now, with this assignment I have here for you guys, okay, what I'm wanting to do is I'm wanting to see how insulator thermal heat energy and temperature are related, and for you guys to see exactly how energy really flows and how this kind of works. Okay, so now, for instance, up here, I have provided the definitions of these things for you right here. So, a substance which does not readily allow the passage of heat or sound or energy in particular is an insulator. And then I want you on here to give me some examples. Okay. And then thermal heat energy in the form of heat. Okay. And also with this, I want you to give me some examples of things that contain thermal energy, or how we know that we have thermal energy present, things like that. Okay. Also, you can give me situations where thermal heat energy is being transformed or transferred to other forms. That's fine. Then we have temperature, a measure of the amount of thermal energy present in an object. Okay. And down here, obviously, you can give me some examples. And I know that you're going to tell me, like 78 degrees or something like that. But give me some examples of how we can measure this, how it differs, how it can go up and down, things like that. All right. So then you guys have to, down here in these two boxes, tell me how thermal energy and temperature are related. And over here in insulator and thermal energy, tell me how those two are related. Okay? Tell me how those two are related. Down here in this, give me some examples or pictures. Give me some pictures. Draw me some stuff. You can find stuff from the web, but I want to see pics here of some stuff that are including these things. All right? And then down here, we're trying it all out. So now, in a game of pool shown on the right, a player is about to use her stick to hit the white ball. That's called a cue ball. And the pool stick is called a cue. So the cue ball then will hit the other pool balls depending on how it's aimed. So when the player starts to move the stick, it has a certain amount of energy. You can tell because it's moving. That's how we know we have kinetic energy for sure. So where does this energy go next? So from the cue or stick, whenever it hits the cue ball, where does that energy go? Now, if you're watching the game, what observations would prove it? So, for instance, right here, you would say something along the lines of energy transfers from the stick to the cue ball and will continue to move until it transfers its energy into the other. Hang on a second. The other pool balls. So we have energy from the stick, or from the stick. It'll transfer from that stick to the cue ball, and will continue to move until it transfers its energy into the other pool balls, and so on and so forth, until they reach their stop or the pocket where those balls fall in, right? So that's how we know the energy is being transferred. That's how pool works. So then where does the energy go? If you're watching the game, what observations would prove it? So up here we have to talk about what observations would prove it, okay? We would observe the pool balls colliding, and the initial ball, or the cue ball, would stop, and the energy is all focused on the next pool ball. Okay, so that's how we'd explain this with pool. All right, now I'll move this over a little bit. That's kind of what I'm looking for here. Then where does the energy go after it goes into those pool balls? A hint, I gave it to you in this first one. If you're watching the game, well, observations would prove it. Finally, where does it end up? How do you know? So you're going right down this list, okay? So we would talk about how the energy will go from the cue ball to the pool balls here and how it ends up in the pocket. How do you know? You observe it falling in. How does this game of pool show the law of conservation of energy? First off, we have to know what the law of conservation of energy is. Energy is not created or destroyed. It just changes form. So how can we look at this game of pool and know that it is that law of conservation of energy is taking place here? Okay. And I gave you all too much information up here in the first one. Really how this should go is this energy should go right here. So energy transfers from the stick to the cue ball, and will continue to move until it transfers energy. Will continue to move until it transfers its energy. And then we go down here to the other pool balls, and then they will knock into each other. And then finally, it will end up in the pocket. And then we have to talk about our observations that we see because of this. Now, this one, try it on your own. So the picture on the right here shows last year's winner of the World Belly Flop Contest in the middle of his winning dive. Now, imagine you are a sportscaster covering the event for ESPN, but you want to teach your audience a little something about science. So on a separate sheet of paper, what you guys are going to do is you're going to add a sheet right here. Okay. Now it's going to ask you, I'm going to upload this for you all to make it another sheet right here. All right. Now there's going to be another sheet of paper present. On a separate sheet of paper, write down what you would be saying. Make sure to answer the following questions. What is the event like? What will happen when the belly flopper hits the water? How do you know that he has energy? Where will his energy go when he hits the water? Think about the ripple effect, okay? So these are the questions that we kind of went through here that you guys are going to be talking about in another event. All right, guys, you have today and tomorrow to finish this. I am uploading this video with this assignment. I will add this other page here. And guys, I hope you all have the best day. And if you need anything, please reach out to me, okay? All right, guys, I'll see you all soon.